I'd like to welcome you all out to today's webinar on air quality and microbe reduction. Wanted to thank you for taking the time out of your busy days to join us. Today, we should be about a half an hour is what we're shooting for. And the purpose of this webinar today is to cover indoor air quality and microbe reduction. This is not going to be an in-depth dive into the technology behind some of the products or resources that we're going to discuss today. However, we're meant to educate you on some of the best technologies that are available so that we can have you start asking better questions as you go about looking to protect the occupants that you work with, whether that be through schools, whether it be through businesses, or whether it be through your own home. So my name is Matt Ballard. I will be your host and your presenter today. Wanted to also thank Nick Ballard and Jason Stokes for helping out manage the chat and questions this afternoon. So if you do have any questions throughout the presentation, use the question and answer box, and we'll go ahead and address those at the end of the presentation. So let's go ahead and get into it today. Now, just wanted to give you a heads up that you will see the audio disappear for a little bit here during the presentation. We'll join you again back at the end. So when we talk about indoor air quality and microbe reduction, everything needs to be framed properly. And the framing that we need to talk about is 100% in relation to the problem that we're trying to mitigate. Now, in today's environment with COVID-19, obviously the big concern is the coronavirus. And so when we look at the coronavirus in particular, we want to be able to understand the size of that virus versus the type of technology needed in order to eradicate those things. So when we look at comparison, the coronavirus is really about 0.12 microns in diameter. And 1 micron is 1/25,400th of an inch. And this is 1/10 of 1/25,400th of an inch. That's a super, super small particle. In relation, HEPA, so high efficiency particulate arrestants, is rated at 0.3 microns. So we're 1/3 the size of what HEPA is typically rated at. And we can see in the images here how big the coronavirus is and compared to a normal bacteria or PM 2.5, which is particulate matter 2.5 and is a standard in testing air filtration. We can compare that to the size of red blood cells, and also to particulate matter 10 microns and larger, which is smaller than your typical household dust. Now, most of the information that we're going to be discussing today is really recommendations that come from ASHRAE. Now, ASHRAE is the American Society of Heating, Refrigeration, Air Conditioning Engineers. And they've kind of set the standard for the heating and air conditioning industry. Now, during the COVID-19 pandemic, so earlier in 2020, ASHRAE released a document called Guidance for Building Operations During the COVID-19 Pandemic. And in that document, they went into 4 areas of concern that need to be addressed with indoor air quality in order to keep occupants safe. The first thing that they address is ventilation. The second thing is humidification. The third thing is air filtration. And then the fourth thing is what's called UVGI, or air purification. And UVGI is ultraviolet germicidal irradiation. It will also be referred to today as UVC, or ultraviolet C light. Now, what they tell us is that when we can impact or improve these 4 functions of indoor air quality, we can create a safer environment for occupants. And that's what we're going to be discussing today, is the 4 areas of concern of indoor air quality and what we can do to improve them in order to be more effective at protecting our building occupants against the pandemic. Now, first, let's talk about ventilation. So how does ventilation impact the spread of airborne bacteria and viruses? What ASHRAE tells us is that ventilation and filtration provided by HVAC systems can reduce the concentration of the SARS-CoV-2 virus, and thus we lower the risk of transmission through the air. And something that will help us to remember the importance of ventilation is dilution is the solution to pollution. Now, what that can help remind us of is the importance of not breathing each other's air. When we're locked in buildings and classrooms and offices all day long, all air conditioning systems will typically do is recycle or recirculate the same air that we've all been breathing all day long. Now, when we add fresh air introduction into that equation, we can decrease the concentration of that recycled air over and over again. So instead of breathing the stale, stagnant, sick air, we can breathe a much cleaner, healthier, fresher air. Now, ASHRAE has given us some guidance as to what we need to do to improve ventilation. Now, in many of the jurisdictions that we find ourselves in, there is already building code that requires fresh air ventilation. Now, that code requirement will typically go back to ASHRAE's guidance, which is what they call 62.2 or 62.1. And these are regulations or recommendations from ASHRAE in terms of how much fresh air ventilation is needed. Now, one of the recommendations that they give us is to disable demand controlled ventilation. That's ventilation that is controlled by CO2. So if we get high levels of CO2 in a conditioned space, it will automatically ventilate. And their recommendation to disable that is because they're really recommending that we have constant fresh air introduction. That's why they also recommend to open fresh air dampers as high as 100% to eliminate that recirculation. Now, we have to put these things into context, is that if we disable demand controlled ventilation and we open fresh air dampers to 100% of what they're capable of, we may be causing some other unintended consequences, like being able or not being able to condition or heat or cool a space as needed. So it's important that we have a balanced approach to looking at all of these recommendations, starting with that ventilation. Okay. Now, the importance of ventilation has been known for buildings for such a long time. There's many studies that are available that will link inadequate ventilation to things like poor classroom performance, poor school attendance, poor attendance in the place of business. And in this study referenced here, Washington State University actually tells us the importance of that fresh air ventilation and what the negative impact of high levels of CO2 concentration can be with students and faculty. And just as a side note, all of the information that we're discussing today during the webinar is available on our website for reference at garypacific.com/IAQ under our resources segment. Now, with ventilation, we have to take some precautions, okay? So we know that ASHRAE's recommendation is make sure that we're sized properly, that we have the adequate amount of ventilation. The second thing is to disable the demand control ventilation where possible. And the third thing is to open fresh air dampers as high as 100% to eliminate recirculation. Now, some of the precautions, when we do those things, okay, and when we take other measures to increase the amount of ventilation that we have in an occupied space, we potentially open ourselves up to other problems, okay? So leaving doors and windows open, or again, increasing the amount of outdoor ventilation, if not filtered properly, we can introduce other problems like allergies and asthma, or triggers that cause those problems to become much worse. One of the other things that we have to remember too, especially in a school environment, is that by leaving windows and doors open, we also leave ourselves open to noise pollution, to where we cannot get the same level of focus out of our teachers and students when we have all of that outside noise going on around them. And there's also safety concerns associated with leaving doors and windows open. And so while this may be the easiest way to ventilate a conditioned space, the safest way is to do it with fresh air ventilation systems that are incorporated into the heating and air conditioning system of that occupied environment. Now, the second aspect that ASHRAE talks with us about is humidification. So how does the level of humidity impact the spread of airborne bacteria and viruses? Now, this one's actually really interesting. So from a recent study, and this study actually comes from the University of Sydney in Australia, in conjunction with the School of Public Health out of Shanghai, China, there's a direct correlation between the level of humidity and increases in cases of SARS-CoV-2 or COVID-19. Now, what they tell us is overall a decrease in relative humidity of 1%. So as humidity goes down 1%, was associated with an increase in cases of 7 to 8% on average. Now, the big question is why? Why is humidity directly linked to increases or decreases in cases of COVID-19? And it really comes down to healthy levels of humidity and what happens in those environments. Now, this chart actually comes from ASHRAE. They have given us the healthy level of humidity. That healthy zone is between 30 to 60% relative humidity. And in the study from University of Sydney, what they actually told us is that around 40% relative humidity is where they could see a decrease in the number of transmissions of COVID-19. And the theory behind that is twofold, is that between or in our healthy zone of 30 to 60% relative humidity, two things happen. Number one, the airborne contaminants, like the SARS-CoV-2 virus, will not remain airborne. It will be able to absorb small levels of moisture, making it heavier and fall from the airstream. And we know from countless studies over this past 12-month period that a lot of the transmission of that virus is due to aerosols. So it's important to remember that if that virus is not in the air, it is less likely to be inhaled or absorbed into the body, and somebody is less likely to become infected. Okay, so the first part is that we can weigh down that virus, add additional weight to it, and pull it out of the airstream so it's not as easily inhaled. The second aspect too is that between that healthy zone of 30% relative humidity to 60% relative humidity, viruses and bacteria just don't reproduce as effectively. In fact, in many hospitals throughout the country, they have a target level of humidity of between 50 to 55% relative humidity. And when we look at the environment that we find ourselves in, oftentimes it's very difficult to be able to control the level of humidity. Now, when we look at it from the perspective of a home, we can add whole home humidification systems to somebody's house and be able to maintain a healthy level of humidity fairly easily because we're not having a huge influx of fresh air. We also have a very controlled environment. And especially with new homes, we have much tighter construction, which allows for the level of humidity to be regulated properly. Now, when we try to take that technology of adding humidification or potentially dehumidifying, removing moisture from, let's say, a classroom setting, it becomes much more difficult. Anytime that we introduce high volumes of fresh air, like ASHRAE's recommendation, we're going to negatively impact that level of humidity within the space. And so earlier when I mentioned that we need to take a balanced approach, we have to understand that adding humidification systems oftentimes to classrooms or office buildings is going to be extremely difficult and not really a practical aspect to fighting airborne bacteria and viruses. And oftentimes being able to manage the level of humidity inside a conditioned space can be done through proper ventilation and through the dehumidification process that is present anytime an air conditioning system happens to be running. So between ventilation being the first thing that ASHRAE recommends and humidification being the second, the third aspect of indoor air quality that ASHRAE recommends to be addressed is air filtration. So how does air filtration impact the spread of airborne bacteria and viruses? Now, in order to understand that, let's go back to the very first slide where we talked about the size of the particle. The coronavirus particle is 0.12 microns, very, very small particle. And what ASHRAE has given us is they've given us what's called a Merv rating chart. And Merv stands for minimum efficiency reporting value. All it is a way to determine how efficient an air filter is at capturing particles of particular sizes. Now, in particular, when we look at what we're seeing right now, Merv 5 through 8, they rate these particles in 3 different size categories. So you have particle size removal, and you notice that there is no rating. That is rated at 0.3 microns. You have arrestance, which is designed for really large particles. And then we see dust spot efficiency, which is designed for some of the smaller particles. Now, ASHRAE's guidance was that, well, excuse me, back up just a second here. Most buildings that we look at now will usually have air filters that range between MERV 6 to MERV 8. That is a standard MERV rating for a lot of applications. There are school districts all over the country that use filters that are rated below MERV 8. That is normal, okay? Now, anytime that we increase the MERV rating on an air filter, there's some other things that we have to think of. Is as that air filter becomes more restrictive, what is it going to do to airflow? Because if the air filter is restrictive enough to capture fine particles, it will decrease the amount of air that moves through the system, which can cause a whole bunch of other problems with HVAC operation, comfort, efficiency, reliability. So as we look to higher efficient air filters, MERV 9 up to MERV 12, we can see that we get an improvement with large particle reduction. But in order to actually focus our efforts where they need to be on those super small particles, we have to start talking minimum of MERV 13. And that is ASHRAE's guidance, is that where possible, we need to improve central air filtration to at least MERV 13 or the highest compatible MERV rating with the filter rack, and seal the edges to limit air bypass around the air filter. Now, when we look at MERV 13, that particle size removal is rated at 0.3 microns. So at 0.3 microns, a MERV 13 filter should be able to capture more than 75% of 0.3 microns. But again, the problem that we have here is that the coronavirus is 0.1 microns, okay? So that's 1/3 of the size that that MERV 13 is rated at. Now, one of the deficiencies that we have with the MERV test is that MERV ratings do not test for particles below 0.3 microns. So while we look at a MERV 13 and say that's getting pretty good at very small particles, we still don't know exactly how efficient that MERV 13 filter is going to be at the size of the virus that we're trying to make sure and protect ourselves from. Now, when we look at the difference in terms of operation between a MERV 13 and say a MERV 16, which is the highest rated MERV in the MERV scale, is we can see that there is a pretty significant difference between a MERV 13 filter and a MERV 16 filter at the size of particle that we want to be able to capture. And so ASHRAE's guidance was to increase your MERV rating to a minimum of 13 or higher. And one of the biggest problems that we have anytime we go higher than MERV 13 is that those filters become so restrictive on airflow that they can cause significant damage to heating and air conditioning systems. They can cause compressors to fail, motors to fail. They can cause uneven or uncomfortable temperatures in the conditioned space, which cause all sorts of other problems. Now, up until recently, the technology behind air filters was fairly stagnant. There hasn't been a huge increase in higher efficiency air filters until just the past couple of years. And so one of the purposes behind this webinar is we've got to understand that there are better options out there where we can still provide very, very high levels of air filtration, MERV 16 or above, and not be able to negatively impact the air conditioning system at the same time in terms of that restriction. Now, there happens to be an air filter. It's a MERV 16, what's called an infection control air filter, that has been tested beyond the standard MERV scale. Okay, so MERV goes up to MERV, or the MERV chart goes up to MERV 16, and that's as high as it goes. So it only rates those the efficiency on that filter at 0.3 microns. And one of the problems that we have, again, is that virus is smaller than 0.3 microns. And so there's another test, which is a lot more common in Europe, called the EN 1822 test. Because MERV does not show the ultrafine particle range, that's why the EN 1822 test exists. And with this particular filter, we can look at a particle at zero point 0.1 microns, the size of the coronavirus, and actually see how efficient that filter can be. So with this particular filter, the Merv 16 infection control filter, we're able to see a much, much higher efficiency than we would get out of a standard Merv 16 filter. When we again look at the coronavirus at 0.1 microns, the infection control filter has about a 97% effectiveness at 0.1 microns. That is the coronavirus sized particle. Now, the really important thing though is that if we're going to have that high of a level of air filtration, that the level of restriction on airflow has to be low enough that we will not cause any negative impact or unintended consequences by improving the level of air filtration that high. And it's possible with this new type of filter. So in addition to that filter being able to capture smaller particles, we can look even beyond that 0.1 microns all the way down to sometimes 0.003 microns and look at the efficiency of the air filter. That's what the testing from EN 1822 brings us. Now, the positive thing here is that, guys, there's technology that can help us right now. We can retrofit these type of air filters into many different types of heating and air conditioning systems, whether they're rooftop package units, whether they're commercial split systems, air handlers, even wall-mounted barred type units can be able to have this type of a filter installed in them without any real retrofit. Now, we've talked about ventilation, the importance of bringing in fresh air. We've talked about humidification, the importance that that plays in terms of the viral transmission. And we've just addressed air filtration. Now, the last thing that ASHRAE recommends is that we consider air purification. And so we're going to talk about 3 different technologies of air purification and how they can potentially help protect our occupants against COVID-19. Now, one of the first technologies that we do need to address, because it's become extremely popular during the past 12 months during the pandemic, is what's called bipolar ionization or corona discharge. Now, the way that these units work is they use an electrical charge in order to release negatively and positively charged ions, or what are considered reactive oxygen species, or oftentimes can be referred to as hydroxyl radicals. And these things are supposed to go out into the conditioned space and kill, sanitize, neutralize bacteria and viruses. Now, what's really important to know is that this technology, bipolar ionization, has actually been around for a very long time. However, when it was first introduced into the heating and air conditioning market decades ago, it was not released into the market with the intention of it killing bacteria and viruses. It was released with the intention of, if we can clump airborne particulates together and make them larger, our air filter will be more efficient at removing contaminants from the air. Now, ASHRAE does not actually have an official stance on bipolar ionization, but the CDC does. And so Centers of Disease Control tells us that when considering bipolar ionization, we need to do some research. They tell us that one of the first things that we need to look at with bipolar ionization is its UL 2998 rating to ensure that there are no harmful levels of ozone emitted as a byproduct of these devices. They also tell us that there's a less documented track record in HVAC systems, including systems that use large volumes of air. And they actually tell us to exercise caution and do your homework. Now, just this past week and a half ago, it was actually on February 23rd, Johns Hopkins University, they hosted a webinar where they addressed concerns about bipolar ionization. Now, in that webinar, we actually had Dr. Richard Corsi. He's the Dean of the College of Engineering at Portland State University, field a question in regards to how bipolar ionization can be a part of a school's HVAC system and an effective countermeasure to COVID-19. And Dr. Richard Corsi said, and I quote, "I believe in rigorous peer-reviewed publications on technology For things like HEPA air filtration, and you know that Merv rated air filters and mechanical systems, there's decades and decades of peer-reviewed literature, good research that exists. For technologies like needlepoint bipolar ionization, there are, without mentioning any companies, there are certainly companies that show data that looks really good. But when you break down that data, it ends up being a lot like the data you see for indoor plants. And what he's referencing there is that there's actually studies out that show that having more plants inside the home can purify the air. But breaking down those studies, there's not a lot of efficacy to them. What he finishes saying is you end up getting very low, what are called clean air delivery rates, that are sometimes 10 to 20 times less than you'd get with a good proven HEPA filtration system. And so you have to know that I believe in proven technologies that have been peer reviewed and that the literature has been analyzed by lots of people. And that doesn't exist for a lot of the technologies that are being marketed to schools right now. And I will say, I know one school district that has gone all in on that particular technology. And you know, there's a big question mark as to whether they spent their money wisely. And I wouldn't have done it if I was them. Dr. William Banlift, who is a fellow at ASHRAE and the head of the COVID-19 task force for ASHRAE, followed up and said, and I would add to that, beyond efficacy, these are all technologies that are putting things into the air that aren't ordinarily there. And we have to be very careful about the potential health effects there. And there is some research that shows oxidative stress from high ion levels and production of secondary aerosols that can be hazardous. So there's just a lot of work that needs to be done before we can really have confidence in that group of technologies. Now, the second aspect that is becoming more common in terms of air purification, especially during the past 12 months, is that of ozone. Now, in the state of California, this should not be an issue whatsoever because there are standards in place that you should not be using air purification devices that use ozone as its primary means of purification or that emit ozone as a byproduct of that purification process. Ozone is harmful to health and can cause a number of different symptoms and diseases in the respiratory tract. Ozone should only be used or considered as an option for disinfection in unoccupied spaces, but never around people. Now, the other aspect of air purification is UV light. Now, UV light has a very well documented history in its effectiveness against bacteria and viruses in particular. Now, of all the UV light, we're particularly talking about UVC. It is shortwave UV. It's the type that has been used in the heating and air conditioning system for decades. And what that UV system originally was designed to do is to prevent organic growth from growing on the evaporator coils inside the heating and air conditioning systems. That area is cold, dark, and damp. It is the perfect breeding ground for organic material. Now, when we add UV light to evaporator coils, we can actually reduce coil cleanings. We can increase system efficiency. And at the exact same time, we can destroy airborne and surface bacteria and viruses. And like I said, this technology has been documented and proven for decades. It's so well proven that we actually have charts and data to know exactly how much UVC dosage is needed in order to inactivate hundreds and hundreds of different airborne pollutants. Now, one of the ways that we can actually do that is by using what's called a blue calc. There's the ability to take a real world application, plug in all of the data into our software program that we need in order to see how effective a UV light would be against a particular contaminant. Now, this is a blue calc that we ran for a 4-ton barred wall mount unit. We use some of the standard parameters that we'd see in a normal installation of that type of a unit. And when we put that with a high output UVC bulb, what we can actually see is a 99.99% average inactivation rate of the SARS-CoV-2 virus on a single pass. And we can calculate these things because we know how much dosage is needed in order to inactivate the virus, and we know the output on the UV bulbs that we actually have. Now, one of the manufacturers that we work with, a company called Fresh Air UV, has actually gone to additional lengths to get third-party testing showing that their units, their UVC lights, have the ability to get a 99.99% inactivation rate within 0 to 2 seconds within the HVAC or ventilation system. So this wasn't a surface decontaminated test. This was an airstream disinfection test. And that's the type that we need to be able to look at, knowing the environment that these things will actually be installed with. Now, what's really important to understand is that there is no one solution that is needed to improve our indoor air quality and protect us from airborne microbes. It's a combination of these things that will provide a much safer environment for us, for our occupants, for our students, for our teachers, through our faculty, for our employees, and for our families. Now, with that being said, just remember the intention of this webinar was to give you some information to start the right conversations. And those conversations need to focus around ventilation, humidification, air filtration, and purification. So with that being said, if there are any questions, we can go ahead and open up the Q&A right now if anybody has any questions that they'd like to ask. And if not, please visit our website, garypacific.com/IAQ. You'll see that we have a number of fantastic resources to help give you more education so that that decision-making process on what should be done to help protect the people that we have stewardship over, that we can make better informed decisions. You can also email us at iaq@garypacific.com, or you can also reach out to me through phone or through text at the phone number listed in the presentation or on the slide that you see right now. So again, thank you for your time today. I know your time is valuable. We appreciate it. And if there's anything that Geary Pacific can do to help you along the lines to taking action to protect those people that you're in charge of, please let us know. Otherwise, we'd like to just leave open the questions for another minute here. And if there's nothing else, we'll go ahead and finish for today.